You hear it everywhere, right? Everyone's talking about building these super complex, totally autonomous AI agents. But what if the real secret to making them work isn't about complexity at all? What if it's about simplicity? Well, today we're going to dig into the patterns that are actually working in the real world, based on what teams who have built dozens of these things have learned. So let's dive in.
Okay, let's just put this right at the top. This is the key insight. And look, this isn't just some theory. This comes straight from the folks at Anthropic, people who've seen countless projects succeed and, well, fail. The teams that are winning with AI, they're not getting tangled up in the most complicated frameworks. They're using simple, elegant, and reusable building blocks.
That's the million-dollar question, isn't it? And we're about to break them down one by one. But before we get into the nitty-gritty, we have to make one really important distinction that's going to frame everything else we talk about.
So before we even touch the patterns, you've got to understand the two fundamental ways you can build these things. Are you building a predictable workflow, something that follows a script? Or are you building a truly autonomous agent that thinks for itself? Because the choice you make right here changes absolutely everything.
You know, the difference really just boils down to one word: control. A workflow is like following a recipe. It has predefined steps, it follows the code, which makes it super consistent and reliable. An autonomous agent, though, that's more like a creative chef. It uses the LLM to decide its own steps, to pick its own tools on the fly. It's incredibly powerful for sure, but also way less predictable.
And here's the thing, you don't have to jump straight to hiring that creative autonomous chef. You can build amazingly powerful systems just by using a handful of simple, repeatable workflow patterns. So let's take a look at the 5 most effective ones that people are using right now.
All right, first up, we've got the most fundamental pattern of them all: prompt chaining. Honestly, if you're going to build anything with AI, this is pretty much the bedrock. It's where you start.
Just think of it like a factory assembly line. Instead of giving an LLM one huge, complicated job, you break it down into smaller, bite-sized steps. So maybe step 1 is a prompt to generate some marketing copy. Then the output of that flows directly into step 2, which is a prompt to translate it into Spanish. Yeah, it might add a tiny bit of latency, but the boost you get in accuracy is huge because each step is so much simpler for the model to nail.
Okay, so let's move on to our next pattern, which is routing. If prompt chaining is the assembly line, you can think of routing as the smart traffic controller who's deciding which assembly line each request should go down.
This one is a total game changer for efficiency. Here's how it works. A simple, fast router LLM takes a look at an incoming request and just classifies it. Is this a sales question, a tech support ticket, a refund request? Then, depending on that category, it sends the request to a completely different specialized prompt, or even a different model altogether. You can use a cheap, fast model for the simple stuff and save your big, powerful model for the complex problems. It's a brilliant way to optimize for both cost and performance.
Our third pattern, parallelization, is all about tackling a problem from a bunch of different angles all at the same time. It's about doing more, faster, and frankly, with a lot more confidence in the result.
And this one actually comes in 2 different flavors. First, you've got sectioning. This is where you break a task into independent parts that can run at the same time. Like, you could have one LLM process a user's request while another LLM is simultaneously checking that request against safety guidelines. Then there's voting. This is where you run the exact same task multiple times, maybe with slightly different prompts to get a few different takes. It's like having a panel of experts all review some code for security flaws.
Okay, now things are about to get a little more dynamic. With the orchestrator workers pattern, we're basically introducing an LLM that acts like a project manager.
The big difference from the last pattern is flexibility. Here, you have a central orchestrator LLM that looks at a complex request, say a big coding task, and it dynamically creates a list of all the subtasks that need to get done. Then, it farms out those jobs to different worker LLMs and pulls their results back together at the end. The key is that the subtasks aren't predefined. They're decided on the fly.
And that brings us to our 5th and final workflow pattern. This one is all about creating a powerful feedback loop for quality control. It's called the Evaluator Optimizer.
This pattern really just mimics the human creative process, you know? You have one LLM that's the writer, it generates the initial response. Then a second LLM acts as the editor. It critiques that response based on a specific set of rules or a rubric. This back and forth can continue, polishing the output with each pass. It's absolutely perfect for things like literary translation, where that extra bit of nuance and polish makes all the difference.
Okay, so once you've gotten comfortable with these workflow patterns, you can start combining them to create really sophisticated systems. Or you can even decide to go for a fully autonomous agent. But, and this is a big but, you've really got to understand the trade-offs before you take that leap.
This table pretty much lays it all out. A single call to an LLM, it's fast, it's cheap, but it's pretty limited. A workflow adds more steps, so yeah, cost and latency go up, but you get way more control and predictability. And then there's the fully autonomous agent. It's the most powerful and flexible, no doubt, but it's also the most expensive, the slowest, and it has the highest risk of making a mistake early on that just snowballs. So the golden rule, only add complexity when you can actually prove it makes the result better.
So it doesn't really matter which path you choose, a simple workflow or a complex agent. All of these patterns are guided by 3 golden rules for building systems that actually work, that are reliable, and that you can actually maintain without pulling your hair out.
Rule number 1. Keep it simple. Seriously, always start with the most basic, straightforward solution that gets the job done. Only add another layer of complexity if you have hard proof that it adds real, measurable value.
Rule number 2. Make the thinking visible. Look, when things go wrong, and they will, you have to be able to look under the hood and see the agent's step-by-step reasoning. That kind of transparency is absolutely crucial for debugging the system and, just as importantly, for building trust in it. And rule number 3, craft your interface. Now, I don't mean a user interface for a person. I mean the agent-computer interface. The way you design and document your tools for the AI is just as critical as the prompt itself. You have to make it crystal clear to the AI what each tool does and how to use it.
So the question to leave you with isn't how insanely complex can I make my AI agent? It's what is the absolute simplest pattern that will solve my problem today? Start there. Because if you start there, you'll end up building something that actually works and lasts.